Hello everyone. Today I am going to present you my final project for the computer vision class. So I am going to present you about gesture recognition using computer vision. So this project mainly focuses on sign language recognition. We will go through the motivation of this project and the problem which we are going to solve, and then we will talk about the method we are using and the results we obtained, and then we will talk about the future work, and finally we will go on to a conclusion about our project. Gesture recognition using computer vision is an active area of research that has many practical applications. And sign language is a visual language that enables communication among people who are deaf or hard of hearing. It is an important tool for these individuals to express themselves and to interact with the world around them. However, not everyone knows sign language, which can result in communication barriers and difficulties. This is where sign language recognition technology comes into play. People who are deaf and have difficulty in hearing face difficulties in communicating with the society. The current sign language recognition models have limitations due to being less accurate and not being able to recognize sudden movements of hand gestures. Therefore, this project proposes a sign language recognition model which first makes a custom dataset using collected data for 10 classes, and then it will perform image labeling using open source data labeling tool, and then it will develop the model using TensorFlow Object Detection API and transfer learning, and then we will evaluate the model using TensorBoard. The developed sign language recognition model have 9 main steps. The first step is to set up the paths for the folders to create. Then we will create a label map, and as the third step we will create TensorFlow record. Then we will download the pre-trained TensorFlow model from TensorFlow model zoo. Then we will copy the model configurations to the training folder, and then we will update the config for transfer learning, and then we will train the model. Then we will load the train model from checkpoint, and finally we will detect the sign language gestures in real time. Moving on to the results section of our project, we have got an average precision between 0.693 to 1, and we have obtained an average recall between -1 to 0.705. And if we take the evaluation metrics at the step 20,000, we have got a localization loss of 0.109 and a classification loss of 0.22 and a regularizing loss of 0.08, and the total loss was indicated as 0.41. So if we take the results of the real-time detection model, we have got an accuracy of 93% for the I love you gesture, which was the mostly detected gesture in our model. Then the second one was the thank you gesture, and the other gestures such as play, help, no had an accuracy around 50%. This model uses transfer learning as one method to improve accuracy by using the MobileNet pre-trained model. Furthermore, this project uses OpenCV2 library for image resizing to help the model to learn better features and improve accuracy. Furthermore, the model overfitting can be reduced by using methods like cross-validation, data augmentation, and using more training data. In the future, this project plans to use the ASL dataset, which is the American Sign Language dataset, for training the model. And we plan to develop the source code and modify it to improve the accuracy and to detect sign language gestures with movements. In order to improve accuracy of the model, we can use fine-tuning, data augmentation, image normalization, and preprocessing. To further improve the accuracy of our model, we can use image processing techniques like background subtraction, region-based segmentation, edge detection for processing the training data. Overall, this project made a significant progress towards achieving the objective, and the model's evaluation metrics suggests that it is performing reasonably well. However, it is important to note that the model is yet to be worked on to improve the accuracy over more training data and techniques. Thank you for listening.